Good morning, everybody. This is Bilal talking. I'm the technical training manager at 𝐂𝐨𝐬 Bros Company. Um, Today's topic is going to be about the 2206 engine. This is a Perkins engine. The 2000 series engines, uh, it's a family of three engine sizes. The 2206 engine, the small size, the 2506 engine, which is the medium size, and the 2806 engine, which is the big size. This range of 2000 series families cover a big range of genset kVA size from 350 kVA size all the way up to 750 kVA size. In today's topic, we will be talking about the 2206 engine to be specific. These engines really are not Perkins engines. These are Caterpillar engines. So this engine, for example, which is called 2206 2000 series engine, six-cylinder engine, the cat name for this engine is C13. C stands for Caterpillar, and 13, it is the engine capacity in liters. It is a 13 liters engine. And this engine covers these two genset kVA sizes. The 350 kVA size, where the engine model for this kVA size is 2206A E, electronic engine, of course. 13, that's the engine capacity in liters. TAG2, turbocharged air-cooled generator application 2. While the 400 kVA genset size, the engine model ends with 3. What's the physical difference between both engines? Just the software on the ECM. Sometimes we swap 350 kVA engines. Let's talk in engine models. A 2206 engine tag 2. We can switch it, make it tag 3, just by adjusting the software on the ECM. Depends how is the stock level at our stock. Sometimes we have too many of the tag 2 type. We can swap some to have them as tag 3 and vice versa by adjusting the software on the ECM. Of course, this is done in coordination with Perkins. We cannot do this from our head. We need to coordinate this with Perkins. We do this by downloading a flash file, appropriate flash file to the tag 2, for example, to make it go to tag 3. And we fill up a form, online form on Perkins website, where we will be getting the passwords, the needed passwords to upgrade the software or downgrade the software, okay, to make it go from tag 2 to tag 3 or the opposite. Okay, going back to the engine again. These engines, these CAT engines, or let's call them Perkins 2206 engines, are a MIWI type. What do we mean by MIWI? M stands for mechanically actuated. The E stands for electronically controlled unit injection. All electronic engines, we need to know this, all electronic engines, they do not have a fuel injection pump. That's the difference between electronic engines, which is our engine in this case, and any standard mechanical engine. There is no fuel injection pump. Okay, so if we don't have a fuel injection pump on these electronic engines, the fuel injection pump has two main jobs to do. The first one is to highly compress the fuel that should go to the injectors. The second job is the timing, which means the fuel injection pump should be sending this highly pressurized fuel to that specific injector at the proper time. This is called injection timing. So since that we don't have on these electronic engines fuel injection pumps, this means that somebody else has to do these two jobs that were done by the fuel injection pump. So going back to the M, mechanically actuated. This means that we will be using a mechanical force to highly compress the fuel. Okay, this is the first job that was supposed to be done by the fuel injection pump. How is this done? Let me go to the injector, show you how the injector looks like. And here we go. This is the injector. We are using a mechanical force. That's what M stands for, mechanically actuated, to compress the fuel inside the injector by having a rocker arm at the top of this part of the injector, the plunger of the injector. Another photo to simplify this. Here we go. This is the rocker arm that will be pushing down the injector plunger to highly compress the fuel inside. This is the injector. Okay, so this is the extra rocker arm that we'll be having at the top of any of the pistons on this engine. Okay, its job is to highly compress the fuel inside the injector. Going back to the MIWI topic, the verification. Okay, so this is how we highly compress the fuel. Okay, the second job that was required from the fuel injection pump is the timing, knowing when is the appropriate time to send this highly compressed fuel to that specific injector at the proper time. This will be done electronically. This timing issue, fuel injection timing issue, will be controlled by the ECM itself. That's why we call it electronically controlled. How is this done? Let me go to the injector drawing again. Here we go. This is the injector. All injectors on electronic engines, they have a solenoid. Here we go. This is an electronic solenoid controlled by the ECM. See these two pins? We have two wires coming from the ECM to these two pins of the solenoid. When the solenoid is energized, fuel spraying will take place. If this solenoid is not energized by the ECM, of course, no fuel spraying will take place. How is this done? We will go into more details when we go further with the lecture. So that's how the timing process is controlled on this engine by the ECM. That's why we call it electronically controlled. Here we go. Unit injection. It's not that issue. The main things that we need to know is what do we mean by mechanically actuated and what do we mean by electronically controlled. So again, the 2000 series MIWI engines, we have three engine sizes: small size, where the engine model is 2206, 6 stands for 6 cylinders engines. The medium size engines, MIWI engines, is called 2506 engines, and the big MIWI engines are the 2806 engines. So again, today we'll be concentrating on the 2206, the small engine. And again, this is the range of gensets this engine would cover. Again, as well, it is the same engine, whether it's tag 2 or tag 3. The only difference between both engines is only the software on the ECM. Nothing else is different. There are no physical differences between these two engines. Let's proceed with this. Let me go first to the ECM that we have on these engines. This is the ECM. ECM stands for Electronic Control Module. That's what I mean by ECM. Some people call it ECU, which stands for Electronic Control Unit. It's the same thing. At the moment, we have two types of ECMs on Perkins engines. We have this type, which we have on the 2206 engine and the whole 2000 series engines. It is of the Adam 4 type, because at the moment, all the newly introduced electronic engines, they are equipped with another ECM. The model is Adam 5. So this is the ECM we have on the 2000 series, including the 2206 engine. It is Adam 4. What does Adam stands for you, if you like to know? Advanced Diesel Electronic Management. That's what it stands for. Okay, so this is what we have. This is the ECM we have on these engines. Okay, let me go back up. And here we go, starting from this point. The 2000 series technology MIWI fuel system. We'll talk more and more about the fuel system. Big deal. Benefit, emissions capability. Of course, all electronic engines are considered environment-friendly engines. Why? Because they do not emit that much harmful exhaust gases compared to standard engines. Of course, they will give you more efficiency, power related, okay, because the amount of fuel sprayed through the injectors is almost the exact amount of fuel that will be burning to give you the needed power, compared to mechanical engines where sometimes you see black exhaust smoke. What is black exhaust smoke? It means unburned fuel going out through the exhaust manifold. On these electronic engines, you barely see any black exhaust smoke coming out from the engine. You would only see puffs of black smoke whenever you start the engine, because the engine will be spraying a little bit more fuel to help the engine start, or whenever an impact load is applied on the engine, you will see smoke, black puff of smoke coming up, because the injectors will be spraying a little bit more fuel to help the engine take this impact load. Again, looking at the engine itself, the oil sump on the 2206 looks a little bit different than the same oil sump we have on the other MIWI engines, the 2506 and the 2806. It's a bit smaller. It takes like 40 liters of oil compared to the other two engines, where the bigger engines, the medium size and the big size, they take like 60 liters of oil. The type of oil that we should use on these engines should be the viscosity. First, let's talk about the viscosity first. 15W40. This is the standard that we go with. The type of oil, we prefer to use CI4. That's the type of oil that we should use, regardless of the brand name, whether it's Mobil, Total, Exxon, whatever. We need to know the type, which should be CI4, and the viscosity, which is 15W40. We change oil every 250 running hours. According to Perkins, they highly recommend, or let's put it another way, they recommend changing oil every 500 hours. We do not go with this in our countries, third world countries, because we have an issue with the fuel quality. The sulfur rate is high. The sulfur percentage is high. Let me go back to the page. Here we go. The issue with the fuel we have in our countries, the sulfur percentage is high. It should not exceed 0.1%. Okay, but in our countries, unfortunately, it is more than that. So this will affect the lifetime of the oil. That's why we go with half the recommended running hours. So instead of 500 running hours, we change oil and filters, of course, every 250 hours, just to be on the safe side. As for the coolant, it is highly recommended by Perkins to use the ELC type. ELC stands for Extended Life Coolant. Okay, that's what they recommend. We cannot. It's not recommended to use any kind of antifreeze that you find in your local markets. It's better to go with the ELC type, Extended Life Coolant. The lifetime for this coolant is like 5,000 running hours or even more. Okay. All right. I'm not going to talk about the ECM and the sensors related to the ECM at the moment. Let me skip this momentarily and go to the fuel system first. See how the fuel system works. Okay, here we go. Let me start with the injector itself first. Okay. Looking at the whole fuel system first to make things easier. This is the fuel system. This is the fuel lift pump. Of course, on all engines, we have a fuel lift pumps, all of them. And the fuel pressure is around 60 to 65 psi. This is how much fuel pressure we need from the fuel injection pumps in general, which is enough to pump the fuel from the external fuel tank or the daily fuel tank on the genset itself to get all the way up to the injectors. That's the job of the fuel lift pump. So the fuel lift pump on this engine, it is a gear-driven type. Okay, we have two fuel filters, a primary filter and a secondary fuel filter. This is a 2 microns type. This is a 10 microns type. Okay, very fine and good fuel filters. So the fuel will get from the tank all the way up, get in, get filtered through the primary fuel filter, get out, go to the fuel lift pump, go out again, go all the way through the fuel filter's head to the secondary fuel filter, get filtered, go out, get through this hose to this tip of the head. This is where the head, engine head is. Inside the head, we have one common gallery inside the head through which fuel will be going in to supply fuel to the injectors. From the other end of the head, this will be the fuel return pipe. The fuel will be returning back to the fuel filter's head. Okay? In here, it is not shown. Right down below, in here, in between the two fuel canisters, we have a fuel check valve. The job of the fuel check valve is to make sure that the fuel pressure is maintained at 60 to 65 psi. If the fuel pressure exceeds these numbers, it will open up, bleeding the fuel through the hose, which is not mentioned here. Here we have a fuel return pipe. Through this pipe, the fuel will be going back to the tank. Still, before the fuel goes back to the tank, it will go through a fuel cooler, which is not shown in here. The job of the fuel cooler is to cool down the fuel relatively before it goes back to the fuel tank, because we are not supposed to have the fuel temperature exceeding 55 degrees Celsius. If the fuel temperature exceeds 55 degrees Celsius, this will affect the efficiency of the fuel burning. The fuel will not burn effectively. So it has to be at a temperature below 55 degrees Celsius. That's why on engines that have common fuel rails or fuel going inside the heads, we must cool down the fuel before it goes back to the fuel tank through a fuel cooler, of course. Okay, going back to the injector. Here we go. How does the injector work? In here we have a rubber seal, and in here we have another rubber seal. Okay, this is one of them, and this is the other one. In between these two seals, we have the fuel flowing through the injector and going through the other injector. The fuel pressure in here, in between these two seals, would be at 65 psi, as we mentioned earlier. Okay, so that's how the fuel goes inside the injector. Through this opening, we have one opening only. Fuel will get in, go around the plunger, go all the way up to this area. This is the puppet, which is controlled by this solenoid. Whenever the solenoid is energized, this puppet will be pulled up by the magnetic field. Let me go back to the fuel passage going inside the injector. So the fuel will go in at 65 psi, go around the plunger, go all the way to here, go through this open passage, all the way down to this fuel chamber, and fill up the fuel chamber right below the plunger. And then it will proceed going all the way down and filling up the gaps around the needle. The nozzle assembly here, we have this needle which is a spring loaded. This needle which is spring loaded is blocking these 6 little tiny openings through which fuel should be sprayed. Now, how would the spraying take place? We need two things for the fuel to be sprayed. We need to highly compress the fuel inside the injector. This is done by the rocker arm that we have mentioned earlier, which should push the plunger down to highly compress the fuel in here. Okay? Plus, at the same time, we should have the solenoid energized by the ECM. So these two actions should be taking place simultaneously. the plunger should be pushed down, and the solenoid should be energized as well. The signal from the ECM to the solenoid should be 110 volts DC. Let's see how this works. Let's suppose that the rocker arm will be pushing down the plunger, but the solenoid is not energized. Let's see what happens. The plunger is pushed down, the fuel in here will start to be compressed, but because the solenoid is not energized, the fuel will escape through the same route it came through, all the way out. So no fuel spraying will take place. But if the plunger is pushed down by the mechanical rocker arm and simultaneously the solenoid is energized, the puppet will be pulled up. The puppet, whenever it's pulled up, it will block the passage of the fuel at this point, which means the fuel in here, in this area, will be trapped. So whenever the plunger is pushed down, the trapped fuel here will start to be compressed. The moment the fuel pressure exceeds 5,000 psi, it is enough for the fuel pressure to lift up this spring-loaded needle, and all 6 little tiny openings here will be exposed and fuel spraying will take place. So we need a minimum of 5,000 psi fuel pressure to lift up this spring-loaded needle so that fuel spraying will take place. The maximum fuel pressure that we have on these systems is 30,000 psi. This will take place, whenever we have 1800 RPM engine speed and full load applied on the engine. So this is the range of fuel pressure inside the injector. 5,000 psi minimum, 30,000 psi maximum. This is what we have for these MIUI engines, the 2000 series. What I have mentioned applies also to the 2506 engine and the 2806 engine as well. Okay, so this is the how the fuel system works. Okay, let me mention something as well. On these solenoids, on the injector solenoids, you see numbers just like this one as an example. We call this the injector E13 code. What does this mean? This code would tell the ECM how much are the clearances among the moving parts inside the injector so that it knows how much fuel should be supplied to this injector. Because each injector has a different code, because we have different clearances between these parts inside the injectors. So based on this number, which is a number for a flash file that should be programmed to the ECM knows how much fuel should go in compared to the other injectors. In other terms, the fuel getting in for all 6 injectors would not be the same, but the output, the fuel to be sprayed from the injectors will be exactly the same for all 6 injectors. This is in order to have the best efficient fuel spraying for these engines. If we are using bad fuel or fuel contaminated with water, this is what's going to happen. See this burning? This is due to the presence of water in the fuel, contaminated fuel. Because, water has no lubricity. So it will cause this kind of friction, high friction, and damage to the injector nozzle. These scratches on the puppet are due to the presence of dirt in fuel. In our countries, especially in African countries, we see as well contaminated fuel with chemicals. This would as well affect the injectors as well. So we have to be careful. That's why the filters used on these engines are very efficient. This is a 2-micron filter. This is a 10-micron filter. Sorry, vice versa. This is a 10-micron filter at the primary, and this is a 2-micron filter, the secondary type. Let me talk a little bit about the quality of the filters we are using on these engines. Here we go. I'm talking about the oil and fuel filters as well. They are of the Eco Plus type of filters. They are of a very high quality. Here we go. You know, inside any filter, whether it's a fuel or oil filter, we have corrugated paper. The paper quality is very high and very good. And among the corrugations, they put silicone beads to make sure that the corrugations will not get loose. Plus, they put this nylon strip around the corrugations as well to make it tough. The core inside the filters is made from a composite material, a very tough plastic material. Okay? The upper and lower covers of the filters are of the plastic type, but they are molded to the corrugations, to the corrugated paper. Okay? So this makes these filters very fine filters. Here we go. This is the oil filter. It's of the 35 micron type. And these are the fuel filters, the primary, the 10 microns type, and the secondary, which is a 2 micron type. Okay? Do not use non-genuine filters. If you use non-genuine filters, we have seen this many times at customer sites. They are cheaper, of course, but you will cause damage to the engine. If you use non-genuine fuel filters, definitely you have a big chance that you will damage the injectors. If you use non-genuine oil filter, you might affect the oil pressure in the engine. We have seen many engines running at very low oil pressures because of the filters they use. We encountered an issue with an engine 2506 engine where the engine was damaged because this filter, the oil filter, got apart. Some of the parts got loose. They got through the oil galleries and they blocked one of the piston cooling jets. It caused overheating of that piston, and the piston seized, and the piston was damaged. The liner was damaged, and the customer paid like $2,000 or $3,000 just to fix the engine because of using non-genuine oil and fuel filters. So be careful with this. Do not use non-genuine filters with any electronic engine because these engines are sensitive to dirty fuel and oil, bad oil as well, or contaminated oil as well. So always use genuine filters with electronic engines. Any electronic engine, do not mess with these engines. Use genuine filters. Okay, just one more thing to mention about the 2206 engine. On the 2506 and the 2806 engines, the camshaft is mounted inside the head itself. So there is no push rod. There is direct contact between the lobes of the camshaft and the rocker arms. But for the 2206 engine, the camshaft is mounted inside the engine block. So we do have push rods to to transfer the motion from the lobes of the camshaft to the tips of the rocker arms inside the head. That's one of the differences between the 2206 and the 2506 and 2806 engine. Okay, the camshaft is mounted inside the engine block. On the 2206 engines, we have this greasing point. This is where the fan belt is, where the fan drive is. Okay, so make sure to grease this point every 500 running hours, just to be sure that you will not having a failing bearings for the fan drive. Okay, don't forget this. This applies to the 2206 engine only. We don't have it on the 2506 or the 2806. That's the breather, thermostat, the cooling system. Uh, all the engines we have at the moment up to 1000 kVA size and still going high. The radiators are made from aluminum. They are not from copper anymore. It is aluminum because aluminum are lighter in weight and they have higher thermal conductivity compared to copper. So that's what we have. Okay, looking at the top of the engine, okay, it is a six-cylinder engine, of course. Uh, Six pistons. Usually, we count the pistons 1 to 6 from the front side of the engine. This is the fan side. So this is piston 1, 2, 3, 4, 5, and 6. These are the valves. The white are the inlet valves. The black are the exhaust valves. On all Perkins engines, regarding of the size, always, the inlet valves are the ones facing the front side of the engine, as you see in here. The white valves are the inlet valves, of course. They are facing the front side of the engine. The black valves are the exhaust valves. And all the engines we have, regardless of the size, exhaust valves are facing the back side of the engine, the flywheel side. So keep this in your minds. Okay, now valve and injector adjustments. We need to make valve and injector adjustments every 1,000 running hours. That's what's recommended by Perkins. Every 1,000 running hours. Okay. Let's talk about the valve clearances first. Here we go. It's mentioned here at the bottom. For the inlet valves, it is 0.40 millimeters. That's how much should be the valve lash. Okay, for the inlet valves. For the exhaust valves, it's 0.65 millimeters. Okay, so keep these in mind. 0.40 millimeters for the inlet valves and 0.65 millimeters for the exhaust valves. All right, again, going back to the drawing of the engine. To adjust the injectors and the valves at the same time, you need to turn your engine twice, only twice, and you adjust everything. Okay? How do we do this? It is easy. Let me show you this. On the flywheel side of the engine, you have this flange. It's mounted with two bolts, two mounting bolts. You take off this flange. Okay? And there's a plug in here as well. You take off the plug. If you look through the plug and you turn the flywheel, on the flywheel there is one opening, little tiny opening. This is an indication, okay, that you can see through the plug. What you do, I have a better view from here. Here we go. Through this opening, which is this one, of course, we have this special turning tool. This turning tool should be put in, and its teeth will be engaging with the teeth of the flywheel. With this tool, using a spanner or a ratchet, of course, sorry, you can turn the engine in the proper direction, of course. Okay, this is the turning tool that you'll be using to turn the engine, because we need to turn the engine to make injector and valve adjustments. Here we go again. Through this opening, the turning tool will go in. This is the plug I was talking about. You put a bolt in here and you push it with your finger. The bolt will be touching the flywheel. You start turning the engine with the turning tool using a ratchet. Okay, it's a one-man show. With one hand, you will be turning the engine with the turning tool and the ratchet, of course, and with the other hand, you will be pushing this bolt with your finger. It will be touching the flywheel. You keep turning the engine till you feel that the bolt has gone in this little tiny opening. You can feel it. It will go in like by 2 millimeters. You stop. That's a mark, an indication that pistons 1 and 6 are at top dead center. All right, that's how we do it. Now you need another colleague that should be helping you. The moment you are turning the engine, he should be watching the movement of the rocker arms of pistons 6 and 1 only. Forget 2, 3, 4, and 5. Just he has to concentrate on 1 and 6. So whenever he finds out or see that the rocker arms of piston number 6 are rocking, it means that one is ready on compression, right? and you are turning the engine, the moment the bolt that you are pushing with your finger goes in, you stop, of course, and your friend should tell you which piston, is it 1 or 6, which is rocking. Let's suppose he said that 6 is rocking, which means 1 is ready. So what we do when we get to the proper mark on the flywheel, 6 rocking, 1 ready on compression. I'll go to the table again. Here we go. Okay, here we go. Here it says number 1 is a top center compression, which means 6 is rocking, of course. What you adjust at this moment, the inlet valves of pistons 1, 2, and 4. This is have the engine, right? And at the same time, you adjust the exhaust valves for pistons 1, 3, and 5. Okay? Plus, we need to adjust the injectors of pistons 3, 5, and 6 simultaneously. Okay? When we finish adjusting the inlet valves, the exhaust valves, and these injectors as well, you turn the engine again. Okay? You turn the engine again. One complete turn. I do not need the person who was at the top watching the rocker arms of 1 and 6. No need for this anymore. It's just you turning the engine again with the ratchet, with the turning tool, and pushing the bolt again with your finger till the bolt goes in again in that, little tiny hole in the flywheel side. So when the bolt goes in, it means that pistons 1 and 6 are at the top again. But this time, 6 is in compression, 1 is rocking. So you adjust the other half of the inlet and exhaust valve plus the other half of the injectors. So you adjust the inlet valves for 3, 5, and 6, the exhaust valves of 2, 4, and 6, and injectors 1, 2, and 4. Again, for the valves, the inlet valves clearances should be 0.40 millimeters. If not, you make the adjustments. For the exhaust valves, it is 0.65 millimeters. If not, you make the adjustments. How do we adjust the injector on the 2206? Let me go to the injector. It is very easy. And here we go. This is the rocker arm of the injector, okay? At the tip of the rocker arm, you see this adjusting screw, okay? The bolt, this bolt. You loosen the nut, okay? Let's suppose injector number 1, again, the table. Let me go to the table to make it clear. Here we go, the table again. So if 1 is at top dead center compression, I need to adjust injectors 3, 5, and 6. Let's suppose I need to adjust injector number 3, for example. Let's see how we do this. Again, going up to the drawing. Here we go. Let's suppose this is injector number 3. You loosen the nut, you unscrew the bolt all the way up till the rocker arm is loose. Now what you do with your finger, you tighten the bolt all the way down till it goes no more. With your fingers, do not use any tools, okay? When you finish with tightening the bolt, try to shaken the rocker arm. Make sure there is no backlash, which means no clearances. Whenever you make sure that there are no clearances with a spanner, you tighten this bolt half a turn, 180 degrees. That's all what you need to do. This is how we adjust injector. The injectors. That's how we do it. Okay. Again, let me say this again. Supposing that this is injector number 3, which is ready to be adjusted, what you do, you loosen this lock nut, you loosen the bolt with the tool, of course. Okay. Now you put the tools away, and with your finger, you tighten the bolt all the way down till it no more goes down. Okay. shaking the rocker arm with your fingers to make sure that there are no backlashes, okay? Whenever this is done, with a tool, a spanner, you tighten this bolt half a turn, 180 degrees. This is how we adjust injectors on the 2206 engines. And this will be, repeated for the other injectors as well. So that's how we adjust the injectors on 2206 engines. It is very easy. And we should be adjusting the injectors and the valves as well every 1000 running hours. Okay? That's what Perkins recommends. I hope this is clear for everybody. We will take questions anyway by the end of the lecture, Q&A. No problem. Okay, I think we are done with the fuel system and how to make, adjustments, injector valves adjustments. We are done with this. Let me check for any other helpful information that we should be talking about. This has to do with the engine timing. It's, very straightforward. You know the marks on the gears. This is the camshaft gear, idler gear, crankshaft gear. This is for the water pump. Piston coolant jet. Pistons, just like any other Perkins engine, the pistons have three rings. The upper two are called the pressure rings, and the lower one is called the oil ring or scrapper ring. Okay, let me talk now about the ECM and its related sensors. Let me go all the way up now and talk about the sensors, the ECM and its sensors. That's the ECM. Here we go. Okay, now the ECM, it has many jobs to do. First, it monitors the engine, controls the performance of the engine, making sure that the speed is all the time rated 1500 RPM or 1800 RPM. Okay, plus protecting the engine as well. To do all these jobs, it needs data. This data or information will be given to the ECM from its sensors. We have three types of sensors on electronic engines: temperature reading sensors, pressure reading sensors, and speed position reading sensors. Okay, on this engine, the total number of all these three types of sensors is 8. We have 8 sensors. Let me talk about the temperature reading sensors first. Let me go to the engine drawing. Here we go. ECM temperature reading sensors. We have 3 sensors. Here we have one, the coolant temperature sensor. Always, coolant temperature reading sensors on all engines, even the mechanical engines, it is mounted on the head itself to get the most real reading. Okay, so it is mounted here on the front tip of the head, the ECM coolant temperature sensor. The other temperature reading sensors, we have, this is the inlet air manifold. From down here below, they mounted inlet air manifold temperature reading sensor. One more to go. On the fuel filter's head, we have a fuel temperature reading sensor. These are the 3 temperature reading sensors. We have 3 pressure reading sensors as well. Let's start with this one. Atmospheric pressure sensor mounted here. We will have a closer look at the sensors and their positions whenever we finish from this page. Here we go. This is the atmospheric pressure sensor mounted in here. At the top of the inlet air manifold sensor, here we have the temperature reading sensor, right? For the inlet air manifold. At the top here, we have inlet manifold air pressure reading sensor. Okay. One more to go. the oil pressure reading sensor. It is mounted in here. Okay, two more to go. Speed position reading sensors. We have one in here mounted facing the back side of the gear of the camshaft, and another one as well called the crankshaft speed position sensor, mounted in here facing the gear of the crankshaft as well. Okay, let's look at the location of these sensors. Here we go. Starting with this one. This is the coolant temperature sensor mounted on the front side of the engine head. Okay, this is the location. This is the engine oil pressure mounted very close to the the fuel filter canisters. Okay, on the engine block itself. And this is the fuel temperature reading sensor mounted on the fuel filter's head. Okay. This is the inlet manifold air temperature sensor mounted on the bottom side of the inlet air manifold. Again, at the top of the inlet air manifold, we have the other inlet manifold sensor as well, but this one is reading the air pressure. This is the atmospheric pressure sensor as well. Okay, before I go further and talk about the speed position sensors, let me mention something as well. The temperature reading sensors, how do I know which one is which? Which one is a temperature reading sensor or a pressure reading sensor? All temperature reading sensors on all electronic engines, they only have two wires connected to them. While the pressure reading sensors, this applies to all electronic engines as well, regardless of the model or the type. The pressure reading sensors, they have three wires connected to them. So again, temperature reading sensors, they have two. Pressure reading sensors, they have three. Okay? Why do we need the atmospheric pressure sensor or the inlet air manifold pressure sensor or the inlet air temperature reading sensor? All these three sensors would help the ECM to measure how much oxygen is going inside the engine. Because, whenever you go to higher places like mountains areas, the higher you go, the less oxygen you have. So the engine, based on the reading from these pressure reading sensors, I'm talking about the air pressure reading sensors, of course, atmospheric or inlet manifold air pressure sensor, it can calculate how much oxygen is going in. Based on this information, it knows how much fuel should be sprayed through the injectors so that the air to fuel ratio will stay perfectly set and you will see no black smoke. The air temperature reading sensor, it helps in areas where you have high ambient temperatures like the Arabian Gulf or Africa in general. Whenever you have high ambient temperatures, you don't have enough oxygen in the atmosphere. So this inlet air temperature reading sensor would help the ECM to calculate how much oxygen you have, coming into the engine. Based on this information, it knows how much fuel should be sprayed through the injectors to maintain the proper air to fuel ratio, which will not affect the the exhaust out coming from the exhaust manifold having black smoke. But of course, whenever you use engines at high elevations or where you have high ambient temperatures, this will affect the the efficiency of the engine performance. The power will be less. It will not give you the same power because you don't have enough oxygen in the atmosphere. So the engine will derate. Okay. While if you use a mechanical engine at very high elevations, it will give you black smoke. It might give you some exhaust black smoke. Why? It is still spraying the same amount of fuel through the injectors, even though you don't have enough oxygen. So extra fuel spray will cause black smoke. Okay, let me go now to speed sensors, speed position sensors. Okay, that's what we call them. One mounted facing the gear of the camshaft, another one facing the gear of the crankshaft. Here we go. That's what the sensors will be facing. These teeth, see these teeth? This is where the sensor will be facing. So let me talk first about the speed position sensors. So the sensor, the speed position sensor, it has two jobs. It should tell the ECM how much is the engine speed and the position of piston number one whenever it's ready for fuse spray. Remember when we talked at the very beginning about what E stands for? We said this has to do with the timing of the engine. The fuel injection pump was the one that sends highly pressurized fuel to injectors whenever injectors are ready. Now this is done electronically. It is the ECM job. How would the ECM know that the piston is ready? The speed sensor will tell it. How? Let me go back to the speed sensors again. Here we go. The ECM, whenever piston number one, only piston number one, not any other piston, is ready on compression stroke, this sensor would tell the ECM that piston number one is ready, and the ECM will send 110 volts DC signal to the solenoid of that injector, injector number one. Okay? How about the other injectors? How does it know the location of their pistons? By calculation. It only needs a reference reading for the position of piston number one whenever it's ready at top dead center compression stroke. How does the sensor tell the ECM this? Do you see these teeth? If you look at them, they are equally apart from each other, except in here. They implanted an extra tooth in here. These speed sensors, the way they work, every time the tip of the sensor faces one of these teeth, a 5-volt AC signal, digital signal, will be going to the ECM. Okay? When the tooth goes, the gap comes, a 0-volt AC signal will go back to the ECM. So all the time you have a 505050. But when we come to this extra tooth, what signal? This disrupting signal is an indication for the ECM that piston number one is ready at top dead center. So the ECM, the moment it receives this disrupting extra 5-volt AC signal, it knows that injector number one is ready, and it will energize the solenoid of that injector. As for the other injectors, as I mentioned, injectors 2, 3, 4, 5, and 6, it will calculate. By calculation, it will know the position of these pistons. Okay, so that's how these sensors work, the speed position sensors. Okay, talking about the other sensors, let's talk about the temperature reading sensors. Here we go. This is a temperature reading sensor, engine coolant temperature, whatever. It is a temperature reading sensor. Two wires, as mentioned before, will be connected to the sensor. A 5-volt signal will come from the ECM to the sensor and will go back to the ECM. The range of the returning signal should be between 0.5 and 4.5 volt DC. If the returning signal will be less than 0.5 or more than 4.5 volt DC, an error message will be created by the ECM saying that this specific sensor is shorted high or low. Likewise for the temperature reading sensor, for the fuel temperature reading sensor, or the inlet air temperature sensor. Okay, among these three temperature sensors, only this one, if it gets faulty or really the coolant temperature exceeds 105 degrees Celsius, the ECM will shut down your engine, and you will read on the screen of the control panel, if there is a CAN bus connection between the ECM and the control panel, you will read high coolant temperature shutdown. Okay, as for the pressure reading sensors, we mentioned we have 3 wires. One will be sending a signal, 5-volt DC signal from the ECM to the sensor. The other one is a returning signal, should be between 0.5 and 4.5 volt DC. Okay, the number 3 wire is just a ground wire. Okay, because inside these sensors we have something very close to a capacitor, so you need a ground. So 3 wires for the pressure reading sensors. Which one would cause the engine to shut down if it gets faulty or there's really a problem? It's just the engine oil pressure sensor. If the oil pressure goes below 1 bar or the sensor gets faulty, your engine will shut down. Okay? By the ECM, of course. The speed sensors, of course, if the engine overspeeds for some reason, we haven't seen that much, underspeed, overspeed, the ECM will shut down your engine as well. So the sensors related to protecting the engine and shutting down the engine are the coolant temperature sensor, the engine oil pressure sensor, and these 2 speed sensors. Okay, let me talk just a bit more about the software that you use to get connected with the ECM. And here we go. We can do this as a separate lecture, for the software itself. Here we go. To communicate with the Perkins 2206 engine or the 2506 or the 2806 engine, you need 2 things. You need the software. The software is called Electronic Service Tool, EST. Every year, we have a new version of this software. All the time, they upgrade the software. At the moment, the version that we have is 2021C. That's what we have. Okay? Now, besides the software, which should be licensed, this software should be licensed on a yearly basis. And there's a fee that should be paid to Perkins to get your software licensed. We need, besides the software, we need the connecting tool. The connecting tool, the up-to-date type is called 𝐂𝐴13. This is the drawing for the connecting tool. Okay? This is the adapter and the connections from both ends of the adapter. One goes to the ECM side, the other one goes to the laptop side. The up-to-date type is the 𝐂𝐴3 type, which stands for Communication Adapter 3. This is what we need as a communication adapter to get connected to the ECM by a laptop. Windows 10 would be great as a software, as a laptop, having Windows 10. Okay, but you need the ESD version as well, and it has to be licensed to get connected to the ECM, whether it's Adam 4 or Adam 5 type. So in general, this is what we'll be covering for this lecture, and we'll be taking questions. If you have any questions, please let me know, and I'll be more than glad to answer questions. If you need a copy of the EST, because you can use it for simulation purposes, even if it's not, licensed, it can work as a simulation. Or you need a copy of the lecture itself, we'll be more than glad to give it to you, no problem. Just let us know, no problem. Okay, we can take questions now. Okay, let's start with the first question. Hello, we have a 250 kVA Perkins DG which has issue from oil cooler and spraying mixed oil and water and blocking the NRC valve. Would you explain what is the exact issue and what we should do to prevent this problem in the future? Okay, you're talking about the 1206 engine. Let me first mention something. The moment these engines were introduced, we have an issue with these engines. Every few hundred running hours, we see that the NRS at the top of the engine, the nitrogen monoxide reduction system, will get clogged with soot. Okay, so you need to take it out, clean it, put it back. Sometimes you need to take out the exhaust cooler as well, which is behind the turbochargers. It will get clogged by soot as well. It has to be cleaned and put back. This is mainly the issue with these 1206 engines. Okay, we suffered with these engines. Every time we have to do this to make the engine run again smoothly. Sometimes the exhaust cooler will get damaged as well. You will see coolant going through it, going all the way up to the NRS system. Perkins, not long time ago, they introduced a revised flash file for the ECM, and they asked us to reflash the ECMs, and the problem is gone. We don't see this issue anymore, thanks God. Okay? Now, considering what you have mentioned, the oil cooler, spraying mixed oil and water and blocking the NR. Okay. Usually, we have not seen any oil cooler getting damaged, where oil will be mixing with water. Maybe your engine has overheated or something. Okay, you need to make sure what's wrong here. But if your NRS is clogged with soot, it is clogged by soot. Okay, why? Because the design for these engines, that's how they work. Uh, Perkins is recycling some of the exhaust gases to mix with the fresh incoming air before going to the combustion chambers. Why? To lower the combustion chamber temperatures so that nitrogen monoxide levels will be low coming out from the exhaust. But this created another issue. When you lower the combustion chamber temperatures, you will be causing the buildup of CO2, the soot, which will clog the NRS and clog the exhaust cooler as well. Okay, so that was the remedy for this, the reflashing of the ECMs. Okay, so I think this is the issue you are encountering. Okay, clogging of the NRS because of the soot. That's what you are encountering. Okay, reflash the ECM, clean the NRS, clean the exhaust cooler, reflash the ECM with the new flash file. Okay, another question. I did not get your answer. Do you mean the solenoid of the injector? You cannot, you can just, if you mean you want to check the solenoid to make sure it's clicking or not, you can use any voltage, 60 volt, 70 volt DC on the 2 pins of the injector, and you can hear the clicking, no problem. Or you can use the software to test the EST to test the solenoids of the injectors, if this is what you mean, because your question is not very clear. Another question? Okay, let's read this question. We have 2206 Tech 3 engine, okay? We are facing the issue that under 200 kilowatts, it runs smoothly, but when we increase the load over 200 kilowatts, it starts hunting by changing the frequency. Oh, okay. In this case, first I would check the the fuel system. Make sure that there is no air in the fuel system. Bleed the fuel system well. If it didn't work, you need to go and adjust the gain on the ECM. Okay, you need the EST2 to go and adjust the gain. Okay, you go to configuration tool on the software. You go all the way down to settings. You go to gain. Let's suppose the number is 19,000. The gain number is 19,000. With the engine hunting, it's a trial and error issue. You start to decrease the number, going down in small decrements, 250 at a time, till you get the best result. That's how we solve the issue. Okay? So it's a PID issue. Gain. You need to adjust the gain. Trial and error using the software. But first, check the fuel system. Make sure there's no air in the fuel system. Okay. Any other question? About valve clearance. Isn't supposed to have the exhaust valve clearance larger than the inlet clearance? Yes, it is. 0.40 millimeters for the inlet valve, 0.65 millimeters for the exhaust valve. So it is more. Okay, that's what's recommended by Perkins or Caterpillar, because this is a cat engine. It's up to you. Can the valve and injector timing be carried out less than 1,000 hours? It's up to you. Let me go into more details in this case. What Perkins would say, let's suppose your engine has run 1,000 running hours. You go and start to check the valves for piston number one, for example. If you find out that they are still okay for injector number one, check the others as well. If they are okay, no need to readjust all the settings, for the injectors. Sorry, for the valves, because if one is okay, it means the others go fast through the others with the feeler gauge that you have. If they are all okay, forget it. Do not do the adjustment, because sometimes the engine will run 2,000, 3,000, or 4,000 running hours before you find out really that the adjustments have changed, and you need to readjust again. So double check. If you find more than one piston okay, you don't have to do this at 1,000 running hours. Just skip it. Okay. Okay, gentlemen, thank you very much for your time. Thank you very much.